Just like with MRAM, RRAM, and LRAM, sometimes you want to use trapezoidal approximation even when the height of the trapezoid, or delta x, remains the same. So when that's the case, we can come up with a condensed formula for the trapezoid rule. Using the formula from the previous example, we can condense the y values a bit and factor out the height since they will be the same. So if the heights are the same, we get the trapezoid rule equation is t equals h over 2 times y naught plus 2y1 plus 2y2 all the way until you get to 2 times y sub n minus 1 plus y sub n, where n is the number of subintervals. So then h can be broken up into b minus a over n, very similar to delta x. So in example 2, we're going to use the trapezoid rule with n equal to 4 to estimate the integral from 1 to 2 of x squared dx. And then we're going to compare the estimate with the value using finite integral on a calculator, as well as determining the exact value just by integrating. So the first thing we want to do is determine the height of each trapezoid. So the height is going to be equal to b minus a over n, which is going to be 2 minus 1 over 4. So we get 1/4. So if we want to find h over 2, this is equal to 1/2 times 1/4, which is going to be 1/8. So using trapezoids, I recommend you graph this on your paper or draw a figure so you can draw out the trapezoids. It might be helpful. Here I have it graphed out for us, where the black curve represents x squared from 1 to 2, and then I've drawn in each trapezoid in orange. So if I label these points, I get 1, 1, then I'm going to get 5/4, 25 over 16, and I'm getting these y values from plugging in the x value into x squared. 7 over 4, 49 over 16, and the last one is 2, 4. So it might help to point out that this is x naught and this is y naught. This one's y1, this is y2, this is y3, and this one is y4. So again, x naught, x1, x2, x3, and x4. So using the trapezoid method, we get that the trapezoid is equal to 1/8, which is h over 2, times y naught, which is 1, plus 2 times y1, which is 25 over 16, plus 2 times y2, which is 9 over 4, plus 2 times y3, which is 49 over 16, plus y4, or the last value of y, which is 4. When you simplify all that, you'll get 75 over 32, which is about 2.34375. So that means the integral from 1 to 2 is about 2.34375. Now if we do this on a calculator, we're going to use Math 9. So you hit Math 9, and the integral from 1 to 2 of x squared, dx, you push enter, and you get that the integral from 1 to 2 x squared dx is about 2.3 with a line over it. Now we're going to do it by hand. And you get the integral from 1 to 2 x squared dx is equal to x cubed over 3 from 1 to 2. which is equal to 2 cubed over 3 minus 1 cubed over 3. So 8/3 minus 1/3 is 7/3, which is about 2.3 with a line over it. So you can see that the trapezoid method is very close. Much better than MRAM, actually. Okay, now what I want you guys to do is try this one on your own. Use the trapezoid rule with n equals 4 to approximate the value of the integral, then compare it to the actual value. So take a minute, pause the video, try that on your own. Alright, let's come back together, see if we got it right. So, the first thing we need to do is determine h, b minus a over n, which is going to be 2 minus 1 over 4. So it's again 1/4. So h over 2 then is 1/2 times 1/4, which is 1/8. So the trapezoid rule is the trapezoid is equal to h over 2 times y0 plus 2y1 plus 2y2 plus 2y3 plus y4. So what I recommend to do to get all those y values is actually just make a t-chart or graph it on your calculator. Whatever you need to do to get the values. And we're going to use our x values 1, 5/4, 3/2, 9/4, and 2. And where these numbers come from is because I'm adding 1/4 each time, because that's my delta x value, or my height of the trapezoid. So when I plug it in there, I'm going to get 1, 16 over 25, 4 over 9, 16 over 49, and 1/4. So now all we have to do is plug everything back in. And you get this is equal to 1/8 times 1 plus 2 times 16 over 25 plus 2 times 4 over 9 plus 2 times 16 over 49 plus 1/4. And when you work all that out, you get this to be about 0.508. Now let's work it out by hand to see if we get the same thing. So we integrate from 1 to 2, 1 over x squared. Now it's important to know how to do this one by hand. So what you do is you integrate from 1 to 2, x to the power of negative 2 dx. Just like when we took derivatives, we want to write it with a negative power. So when we integrate, we're going to add 1 to the exponent and then divide by the new exponent. So if I add 1 to negative 2, I'm going to get negative 1, and I divide that by negative 1. And this is from 1 to 2. Another way to write that might be a little bit easier is negative 1 over x from 1 to 2. So this is equal to negative 1/2 minus 1 over 1. Again, I'm leaving this negative outside of my parentheses. I'm just going to work with this. And negative 1/2 minus 1 is negative 1/2. So your answer is 1/2, which is 0.5. So you can see that with the trapezoid approximation, we're still pretty close to what we got even when we just integrated it.